A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss the topic conjugate number. So conjugate number, first of all, see conjugate of a complex number. Conjugate of complex number. Conjugate of complex number. So what is conjugate? Let Z be a complex number such that Z is equal to x plus iy for all x comma y belongs to real. Then the conjugate of complex number Z is denoted by Z bar and defined by Z bar is equal to x minus iy for all small x comma y belongs to real. So this is the definition of conjugate number. Note point. To obtain the conjugate of complex number, to obtain the conjugate of complex number, what we have to do? Replace I by minus I. This is the method. Now this is the definition of conjugate of complex number. Now see, now I will come to the properties of conjugate of complex numbers. Now see, Properties of conjugate of complex number. Properties of conjugate of complex number. Now see, the conjugate of complex number z is the same complex number. See, first property is the conjugate of complex number is same complex number. Same complex number. Same complex number. This implies this is the conjugate of any complex number, and when you will take double conjugate, so you will get same result. So this is the conjugate of complex number is the same complex number. See, now second is the sum of complex number and its conjugate is real number. Is real number. Now you can see this is any complex number and this is the conjugate of complex number, and when you will sum, so what you will get the result? You will get x plus iy plus x minus iy for all x comma y belongs to real, and its result will be z plus z bar is equal to 2 times x, and 2 times x, what we can write? We can write z plus z bar is equal to 2 into real part of z, means this is real number. Now see, This implies what we can write? Now z plus z bar is equal to 2 times real part of z. This is the formula. Can see. Now third property. Suppose you are going to subtract. So what you will get the result? The third point is suppose you are going to subtract. Now third point is the subtraction of complex number to its conjugate is imaginary number. Imaginary number. And now we can write this is the complex number and this is its conjugate. So x plus iy minus x minus iy for all x comma y belongs to real. Now its result will be z minus z bar is equal to 2 times iy, and this is the real part of y, means what imaginary part. So what we can write? This one we can write z minus z bar is equal to 2i imaginary part of z. So this is the formula, means z minus z bar is equal to 2i imaginary part of z. This is the third property. Now the product of complex number to its conjugate, what will be result? See, the product of complex number to its conjugate, its result will be square of their modulus. So what we can write? The product of complex number to its conjugate is square of their modulus. So see, this is the complex number and this is their modulus conjugate, and when you will multiply, so x plus iy, x minus iy, and this result will be x square plus y square, and this result we can write, mod of z whole square. Now z into z bar is equal to mod of z whole square. Now we can write z into z bar is equal to mod of z whole square. This is the formula. Now this is the fourth property. Can see. Now I will come to the next. The sum of the conjugate number or sum of the conjugate of the sum of two complex number is equal to sum of their conjugates. Now fourth property is fifth is, not fourth. So for any two complex number z1 and z2, the conjugate of the sum of two complex number is always equal to sum of their conjugate. So what we can write? Z1 plus Z2. This is the sum of conjugate of the sum of two complex number is equal to sum of their conjugates. Now this is the formula. Similarly, we can write the difference of or conjugate of the difference of two complex number is always equal to. Now sixth is the conjugate of the difference of two complex number is always equal to difference of their conjugates. So what we can write? We will have the formula. This is conjugate of the difference of two complex number is equal to difference of their conjugate. This is the formula. This is the formula. Now property number 6 is completed. Now 7th number property is property number 7th. The conjugate of the product of two complex number is always equal to product of their conjugates. Now 7th is the conjugate of the product of two complex number is always equal to the product of their conjugate. Now what we can write? We can write Z1 Z2 conjugate is equal to Z1 conjugate into Z2 conjugate. Similarly, 8th is the conjugate of the quotient of two complex numbers is always equal to the quotient of their conjugates. So what we can write? We can write Z1 by Z2 conjugate is equal to Z1 conjugate upon Z2 conjugate. Now this is the formula. Can see